Hello friends, welcome to the PD physics classes. In last lecture आपण पाहिलं होतं की the drawbacks of Rutherford atomic model were removed by the Bhors by making certain assumptions we know it as a Bhors postulate. In today's lecture we try to find out the radius of Bhors orbit and velocity of electron. And another important formulas like linear momentum, angular velocity, time period, frequency, and the centripetal acceleration. So let's start. Consider an electron is revolving around the positively charged nucleus. Consider an electron is revolving around the positively charged nucleus in a circular orbit of a radius r. So, as we know that for the circular motion of the electron, the centripetal force is necessary, and that necessary centripetal force is provided by the electrostatic force of attraction between this negatively charged electron and the positively charged nucleus. Then, according to the Bhors' first postulate, that centripetal force is equal to the electrostatic force. Now, if m is the mass of an electron and it revolving with a linear velocity equals to v, then the magnitude of this centripetal force is equal to that mv square divided by r is equals to 1 upon 4 pi epsilon naught into e square divided by r square, where this epsilon naught means the permittivity of a free space. The medium presented here is a free space, so that epsilon naught stands for permittivity of a vacuum or free space having value 8.82 into 10 to the power minus 12 coulomb per Newton meter square. Now we can write this equation as mv square is equals to, we transpose this r towards this side, it becomes 1 upon 4 pi epsilon naught into e square divided by r. So 1 r get cancelled here. So v square is equals to, we transpose this m towards this side and it goes to the denominator. So 1 upon 4 pi epsilon naught, or we can simply write it as a e square divided by 4 pi epsilon naught r into m. So call it as equation number first. As the electron revolving in that circular orbit, we consider that it is revolving in a stationary orbit. If it revolving its stationary orbit, that means its angular momentum is equal to the integral multiple of h over 2 pi. According to the Bhors' second postulate, the electron revolving in a stationary orbit without radiating energy, when its angular momentum is equal to the integral multiple of h over 2 pi. So according to the Bhors' second postulate, so here according to Bhors' second postulate, according to the Bhors' second postulate, we can write it as a mvr is equals to n into h over 2 pi, where this n means the principal quantum number or number of orbits. We consider here as a n orbit. So this n stands for the principal quantum number, or we simply call it as a number of orbits. We find out the radius for the nth orbit, and where h is called the Planck's constant, or it stands for the Planck's constant having value 6.63 into 10 to the power minus 34 joule second. So next v is equals to n into h, this m and r transposed to a denominator, that is 2 pi m into r, or r into m. Call it as equation number second. put the value of V, put the value of V in equation 1. Put the value of V in equation 1. So that equation 1 becomes, it becomes this squaring on both sides. So V square, that means N square H square divided by this 2 square 4 pi square M square into R square is equals to E square divided by 4 pi epsilon naught R into M. So this 4 pi R into M transpose this side, and this equation becomes N square H square divided by this 4 get cancelled, pi over pi square get cancelled, so here remain only pi R into M. It is equals to here on this side E square divided by epsilon naught. Therefore, by transposing this, that equation becomes pi M E square into R is equals to epsilon naught into H square into N square. We find out the radius, so R is equals to this pi M and E square transpose and goes to the denominator, that epsilon naught H square into N square divided by pi M E square. So this is the for nth orbit, the radius of Rn is equals to, we can simply write it as Rn is equals to epsilon naught H square into N square pi M E square for nth orbit. This is the expression for radius of n orbit. So this equation can be written as, we call it equation number 3, and this equation can be written as Rn is equals to epsilon naught H square divided by pi M E square into N square. So this epsilon naught, but this epsilon naught H square pi M E square is equal to constant. So this Rn is equals to, or Rn, if these terms are constant, here epsilon naught is a permittivity constant, that Planck's constant, pi 3.14 having next the mass of electron having the value that is 9.1 into 10 to the power minus 31 kg. Then E is the charge on electron having the value 1.6 into 10 to the power minus 19 coulomb. Then all these terms are constant. Then we can say that this Rn is directly proportional to the square of the principal quantum number. So the radius of Bhors orbit is directly proportional to the square of the principal quantum number. That means as the number of orbits are increasing, then the radius is also increases, because the radius is directly proportional to the principal quantum number, square of the principal quantum number, or square of the number of orbits. So as the number of orbits are increases, radius is also increases. So for first orbit n is equals to 1. So radius of first orbit r1 is equals to, this equation becomes epsilon naught h square. For 1 square it is 1, so it is becomes pi m e square. So this is the equation number 4. So from equation 3 and 4, from equation 3 and 4, we can write it as a Rn is equals to, this value becomes the value of R 1. So this r1 into n square. So that rn is equals to r1 into n square. If you take the ratio of this radius, that is r1 as r2 as r3, then it becomes square of the back principal quantum number. So 1 square is 1. For second orbit, radius for second orbit, it becomes 2 to the 2 square, 4. Then for third orbit it becomes 9, for fourth orbit it becomes 16 and 20. So it's 1 as to 4 as to 9 as to 16 as to 25 and so on. So this is the expression for the radius of Bhors orbit.